Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is longest palindromic substring. Given a string S, return the longest palindromic substring. What is that? Reads the same forward and backward. Probably you already knew that. Return the longest palindromic substring in S. All right, here's an example. B, A, B, A, D. What is the output? B, A, B is the longest palindromic substring. A, B, A will also work. Both have a length of 3. Anything else we should know here? Length of the string is between 1 and 1,000. Okay. You might consider, well, I could just, enumerate all of the substrings and check and see if they're palindromes and keep the one that's the longest. It's not, well, it's not a bad starting point. I mean, it should work. I don't know if it would work in a reasonable amount of time, but let's I don't know. Let's code it up and see what would happen. All right, so a solution like that would look like this. We have we'll set a variable n for the length of the input string max len. Let's start out at 1 because any single character is a 1 character palindrome, so that's really the minimum that we can get. And before we start, it's like the max we can get. I know I can get at least 1. Start keeps track of where our longest palindrome starts, and then we've got a nested loop. I and J, we're going to loop through, well, we're going to use I to loop through from 0 to n. That is, loop through the length of the string. We're going to use J to start with I and loop to the end of the string. So that is going to generate all of the substrings of string S. We can then check and see if that's a palindrome. There's another function for this. We pass in the string. We pass in the start and end of the string, and we check whether or not the length of this substring that we're looking at is greater than the maximum length that we've already seen. If it is, then we keep track of where the string starts and we update max len. I might change that. Well, actually, let's take a quick look at check palindromes. So the string comes in, low and high come in, and we use a 2-pointer approach to this, where we have a pointer at each end of the string and see if the characters are equal. And as long as they're equal, we keep moving towards the center. And if we get all the way and they're all equal, we'll return true. If they're not equal, we'll return false. That's the check palindrome. What we're going to return finally at the end of this is the substring starting at start and extending to start plus max len. Now, I'm looking at this and I'm thinking the check pal, I wonder, maybe if we did that second, it might be better. This computation seems easier, or yeah, faster. And if it doesn't work, then we don't have to do the check pal. That might save some time. I don't think this is going to work anyway. But let's try running that and see what happens. Well, not running it, but yeah, let's run it first, see what happens. Okay, accepted. We'll submit it. I don't think it's going to work. Oh my God, it did work. Okay. Hang on. Later. Well, that's actually quite a bit better than I thought. I mean, most people got it here. We got it out here. What was our runtime? 167 milliseconds. So most people are at 15, and our solution took about 10 times longer than that. All right, there's a better way to do this, actually. I mean, there's a dynamic programming solution to this, which is really what we want to look at. All right, so I set up a 2D dynamic programming array. It is the dimensions of it are the same as the length of the string. We're using example 1 here, which is the string BABAD. You can see it over here. Some of these are initialized to true already. Those are for 1, 2, 3, 4, and 5. Those are all 1-character palindromes. So our max so far is 1. We're starting at index 0, and I, J, and K, we're going to use those for loop counters. The next thing we want to do is we can do kind of a special case for palindromes of length 2, and we can do that just by looping through the string from the first character to the second to the last character and checking to see if the following character is the same. That would give us a 2-character palindrome. As it turns out, we don't have any cases like that. 2-character palindromes. Okay, so for anything greater than 2, we have a more general approach. We're going to start K at 3. K is going to go to greater than or equal to n. So in this case, it'll be 3, 4, and 5. I will start at 0. Okay. I is going to go to, so let's say K is 3. I is going to go to n, which is 5, minus K. 5 minus 3 is 2, plus 1 is 3. Because K is 3, we can run I as far as index 2, all right? And that'll allow us to check for 3-character substrings. We can't run I any higher than the index of 2 because then a 3-character substring would go past the end of the string. So that's what we can run I to. Now J, we're going to set to I plus K minus 1. What is that? I plus K is 3 minus 1 is 2. All right, so that is the first substring that we're going to consider is from starting at index 0 and going to index 2. All right, so what we check for here is we're going to look at the dynamic programming matrix for I plus 1, J minus 1. That would be 1, 1. Where is 1, 1? 1, 1 is right here. We need that to be true because that says that the character, well, I mean, in this case, yeah, we need that. We need that to be true. And then we can check and see if the string character at index 0, that's I, is equal to the string character at index j, which is 2. And they are equal. They're both b's. So that means that dp at ij, which is 0, 2, 0, 2, right here is true. Okay. The character at index 1 is well, it's obviously a 1 character palindrome, and then we check on either side. Those also match, so now we have a 3 character palindrome. What do? Is k greater than max length? Yes, it is. So now we have a 3 character palindrome. And we set start to I. Start is already the same as I. It's 1. All right. Increment I. I is now 1. J is I plus k minus 1. So J is going to increment to 3. I'm going to go through this again. Is I plus 1, j minus 1. That's this right here. That is true. Is the character at index 1 the same as the character at index 3? They're both A's, so actually, yes. So now if we go to 1, 3, that is also true. It doesn't update anything. The max length is still 3. What's next? I increments to 2. That is going to take j up to 4. Now we check the character in between 2 and 4. 3 is true, but the character in the string at index 2 and at index 4, they are not equal. So that's it. At that point, we would increment k to 4, go through the same process. We need palindromes. We need the dynamic programming matrix to tell us that. Well, actually, let's see what would happen if k goes to 4. I would start again at 0. J would be I plus k minus 1, which is 3. So now we're looking at 4 character palindromes. We look for I plus 1, which is 1, j minus 1, which is 2, 0, 2. Is that true? Yes. Are 0 and 3 equal in the string? No. So we're done with that, and really there are no more palindromes here. I kind of wish we had a better example to work with here, but anyway, that is how it works. We build it up. It's bottom up. Starting with 1 character palindromes, then we can go to 2 character palindromes. We can then go to 3, 4, and so on, making sure that our loop indices 0 and 3, that everything in between those is set to true. Okay, and then check and see if the characters at index I and j are equal, and if they are, then we've added 2 more characters to the palindrome. What we return at the end of this is the start, the string or the substring starting at start and going to start plus max, which is 3. Okay, so in this case it would return BAB. That is a 3-character substring starting at index 0. Okay, let's try an implementation. Okay, so let's step through this. We're going to set n to the length of s, so we don't have to keep referring to s.length. We're going to set up our dynamic programming matrix with dimensions of n by n. We set max to 1 because there's always, a 1-character palindrome. And we set start to 0. Actually, I think, I forgot. No, I left something out here. Do I want to type it? Let me pause while I type it in. Okay. I still feel like, I'm still forgetting something. Okay, hold on. Let's do this. I'll type this one. For int I equals 0, I less than n, I plus dp I equals true. Okay. So yeah, so this is where we started, like really once we get to right here, line 12, that's really where we started with the initialized dynamic programming matrix. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. You think of those as starting and ending indexes. So it's really a 1-character substring. Those are all true. Those are all 1-character palindromes, okay? The next thing we can do is we can do a pass through the string to see if we have 2-character palindromes. As I said, we didn't have any 2-character palindromes in the example, but the way it works is run the index from 0 to 1 less than the length of the string and see if the character equals the following character. And if it does, now you've got a 2-character palindrome. So you set the dynamic programming matrix to indicate that that start and end index is a palindrome. Set it to true, set the start to I, whatever I is, and then set max length to 2 because we would now have a 2-character palindrome. All right, the process for palindromes greater than a length of 2 is we are going to use K as like kind of our length indicator. So let's try 3-character palindromes, and that's going to go all the way up to N in case the whole string is a palindrome. I starts with 0. It goes as far as it can go, provided that we can still get a substring of length K without going past the end of the string. So in the example, I would go, if K is 3, I would go as high as 5 minus 3 plus 1 is 3. I would go, no. I'm sorry. 5 minus 3 is 2, plus 1 is 3. It has to stay less than 3. I can go as high as 2. The biggest index is 4, so that will let us get all of the 3-character substrings. All right, J is I plus k minus 1. In the case of I being 0, it would be 0 plus 3 minus 1 is 2, so 0 to 2. That would be the start and ending index for substrings of length k. All right, now we check that the characters between the start and the end index have already been established as part of a palindrome. That's what this is. And then we check to see if the characters at the start and end index are equal. If they are, then we have a longer palindrome. So we set the dynamic programming index using the start and end index of I and j, set it to true. If we have a new max length, we update max length, and we keep track of where the palindrome started. Because at the end, we want to return not the length, but the actual palindrome. So we have to grab a substring out of there starting at the start index for a length of maxlen. And that should be it. Let's try running it. Compile error, can't find S on line 4. That's weird, it's right here. Wait. I'm sorry, it's a string. Okay. All right, here we go. Let's try it again. All right, and now let's try running it. It should be a better runtime than the first go around. Let's submit and see what happens. Okay, see, now we're getting somewhere. 63. I mean, it still isn't. I don't know. People got it down to 15. Well, it's still about a third of where we were with the enumerate all of the substrings. So let's just take that. We'll take that as a win. This is not a super easy problem. I mean, it's rated medium, but you have to have the insight about, well, like, I mean, how can I use the dynamic programming array to solve this? And the answer is, well, you can use the rows and columns as start and end indexes, and just build it up from 1 character palindromes to two character palindromes, three, and up from there. So, all right, hope you enjoyed it. Please feel free to like, subscribe, comment, and I'll see you next time.